Need to add custom AI tools to your existing FastAPI app without breaking your current endpoints? You'll see how fastMCP from FastAPI converts your entire API into an MCP server in one line, then lets you add new AI-callable tools like this getProduct function alongside your existing routes. The result? A single server that handles both traditional HTTP requests and LLM-friendly tool calls.
Hash assumes the FastAPI app from above is already defined. From FastMCP, import FastMCP. Hash convert to MCP server. MCP equals FastMCP. From FastAPI, app equals app. Hash add a new tool. At MCP, tool. Def get product, product ID. Int, product response. Get a product by ID. Return products, DB product ID. Hash run the MCP server. If name equals main. MCP, run.
This demonstrates the API to tool bridge pattern, where existing REST endpoints are automatically converted into AI-callable tools while preserving their original functionality. The concept transforms a FastAPI application into a dual-purpose server that maintains its HTTP interface while exposing the same operations as structured tools for LLM clients. What makes this distinctive is the seamless coexistence of human and machine interfaces from a single codebase, without requiring parallel implementations. The pattern works through declarative conversion rather than manual rewriting. FastMCP analyzes the OpenAPI schema of your FastAPI app, mapping HTTP endpoints to MCP components based on configurable rules, while allowing you to extend the server with additional tools. This creates a unified interface layer where REST endpoints become first-class tools, complete with parameter validation and type safety, while new tools can be added using the same decorator syntax. This approach solves the integration gap between traditional APIs and AI systems. Instead of maintaining separate interfaces or writing custom adapters, you get an LLM-optimized toolset that stays synchronized with your API. It's particularly valuable for gradual adoption, where you can start by exposing existing endpoints to AI clients, then iteratively refine the toolset with purpose-built components as needs evolve. The trade-off is that auto-converted endpoints may require additional curation for complex APIs, but the pattern provides immediate value with minimal upfront effort. Let's break it down.
Hash assumes the FastAPI app from above is already defined.
This comment establishes a prerequisite. The code assumes an existing FastAPI app instance named app is already defined in the preceding code. It prevents undefined variable errors and clarifies the expected execution context for the FastMCP conversion.
From FastMCP, import FastMCP.
This imports FastMCP, the core adapter that transforms FastAPI apps into AI-callable tool servers. It handles the protocol conversion between HTTP endpoints and the MCP tool schema, enabling direct AI integration with your existing API.
Hash convert to MCP server. MCP equals FastMCP. From FastAPI, app equals app.
This converts your existing FastAPI app into an MCP-compatible server. FastMCP from FastAPI preserves all existing routes while adding AI tool capabilities, eliminating the need to rewrite endpoints. The conversion maintains your app structure while enabling AI model integration.
Hash add a new tool. At MCP, tool. Def get product, product ID. Int, product response. Get a product by ID. Return products, DB product ID.
The @MCP tool decorator exposes this function as an AI-callable tool. FastMCP converts the type hints and docstring into a structured schema that AI models use to understand and invoke the tool. This follows the tool registration pattern. Decorate any function to make it discoverable and executable by AI agents.
Hash run the MCP server. If name equals main. MCP run.
This is the standard Python entry point guard. It ensures the MCP server only starts when the script runs directly, not when imported as a module. Without this check, importing the file would automatically launch the server. FastMCP integration pattern. The conversion from FastAPI to MCP server bridges traditional APIs with AI-native interfaces, where HTTP endpoints become AI-callable tools through automatic schema generation. Tool names in the MCP registry derive from operation IDs, not root paths, so explicit naming in OpenAPI specs prevents surprises. This dual interface pattern lets you serve both human developers and AI clients from the same codebase without duplication.
The endpoint that forgets its URL remembers every possible question